Hello and welcome to the Drawing Free Body Diagrams video tutorial. Here we have 4 wooden blocks in different situations, and we're going to draw the free body diagram for each. We're going to start with the first block. And so we're going to start with an arrow pointing down, representing the force of gravity on that block. So the idea is that the earth is pulling the block downward. So that vector is pointing straight down. Now we have the ramp pushing up on the block, but it's actually pushing up at an angle. So we're going to draw our vector coming 90 degrees out of the surface. So like that. So that's our normal force vector. So we'll just bring that down. The idea is that the center of the block is right here. So that's the center of the block. So we are going to show that that is the normal force, which is the surface pushing up on the block. So Fn for the normal force. Now the block is not moving, stationary, and if you look at our free body diagram, there is a force pointing to the right, but there is no force pointing to the left. This force here is pointing to the right. So therefore our block should be accelerating to the right, but it's not, it's stationary. That means there must be another force pointing to the left, and that force is going to be friction. So there's friction in the surface of the block, right there, pointing up at that angle. So this is our force of friction. And because the block is not moving, that friction is going to be static friction as opposed to kinetic friction, which would be if the block was moving. So now we have this right force countering the left force. We're going to look for any other forces we see acting on the block, and there really is nothing. It's just gravity, the surface, and friction. And so here's our free body diagram. And we'll move on to the next one. Alright, in our next situation we have a block again on a ramp, but this time it's moving. So what we're going to do is start with the easy one, which is gravity. So our block is still on Earth, so we have gravity pulling down on that block. So there's our force of gravity. So just label it Fg for our force of gravity. We're still on a surface, so we have the normal force pointing 90 degrees out of the surface. So that's the surface pushing up on the block. And so that is our normal force, and that is Fn. So normal force. Now this time the block is moving down the ramp, so we don't actually need friction in this case because it says the block is moving this way, and here we have a vector pointing somewhat to the right, so there's a reason why the block should be moving. So we're actually going to go without friction in this situation. And that's actually it. A common mistake is to place a vector this way because we see the motion lines. Even though the block is moving in this direction, just look at the picture. There's actually nothing pulling or pushing the block this way. So this is out. That vector does not exist. And this is our free body diagram right here. All right, moving on to our next two examples. For number 3, we have this situation here. So our block is still on the planet Earth, so we have the force of gravity pulling down on this block. So just do this, and we'll label that force of gravity. We have the surface pushing up on the block, so that's our normal force. This is the surface pushing up on that block. So that right there is going to be our normal force. And this time the normal force points straight up because the surface points straight up. Alright, we have a hand pushing the block to the right. So we're going to show this right here is the force of that hand pushing the block to the right. It's the force of the hand. It's a little far away, so we'll bring it closer. Alright, and we have this block sitting on top of the block we care about, the wooden block. So we're going to show that this block is actually pushing down on the box, just like the box is pushing up on the block. So we're going to just kind of add it. We don't want them to totally overlap, so we'll just put it maybe here or right there. And this is going to be the force of the block on the wood. If you look, we have down forces and up forces. We have a force to the right, but nothing left, so this block should be moving to the right. There may or may not be friction. There's not enough information to know that, and if there's no reason that you have to put friction, then we're not going to put it unless it actually says there's friction. We're going to assume it's frictionless. In this case up here, we had to put friction because otherwise the block should be moving, so friction was required. Alright, for our final block here, well, because our block is still on the planet Earth, we have the force down due to gravity. Bring it down here. So here's our force of gravity. Yeah, let's just move that so we can see it. And the hand threw the block, so we have a force from the hand throwing the block. I guess it's up at this degree, I don't know. But if you think about it, the hand's actually not touching the block anymore. So maybe this force existed at one time, back when the hand was actually touching the block. But right now, the hand is not touching the block. So this force does not exist because the hand is not in contact with the block. And the free body diagram just for forces that are acting on the object at that moment. So the hand is not acting on the block. This hand is, because this hand is actually touching the block. This hand is not, with the exception of gravity and a couple other forces. There's got to be contact. So that's actually it. This is the only force acting on the block is gravity. There's nothing else touching the block. Thank you for watching the Drawing Free Body Diagrams video tutorial.